Okay, before we get into example 4, I want to point out a really important formula that you need to know. It's the distance formula. And you can memorize it, but you all should understand that it really comes from the Pythagoras theorem. That is, if you have 2 points in the xy plane, and I ask you what is the distance between those two, I'm simply asking you for the length of that line. And we could do this, drop a perpendicular and a line straight across to draw that right angle triangle, which would tell us all that we've got an A, a B, and a C, and Pythagoras would give us that. So if I wanted to find C, the length of this line, which is the distance between this point, these 2 points, then that distance would be the square root of a squared plus b squared. How do I know what the length of this line is? Well, I'm going to label this point here x1, y1, and this point here x2, y2. Then the length of this line would be x2 minus x1. That would be the a value. And the length of this line would be y2 minus y1. That would be the b value. So our distance formula comes from that. That is the square root of a squared plus b squared, where a is x2 minus x1 and b is y2 minus y1. Okay, so let's put that distance formula right here. So distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, find the points on this parabola, 6 minus x squared, that are closest to the point 0, 3. That is, we want to minimize the distance between this point and this parabola. Let's do a quick sketch. So, not going to do it too accurately, just accurately enough to know I've got a parabola with a vertex at 0, 6, and it opens down. And this point here, x is 0, y is 3, would be right about there. So the question's asking me to find the point on this parabola that is the shortest distance to this point right here. So here's some options. It could be 0, 6. Length of that line would be 3. It could be 0, 0. The length would be 3. I guess it could be down here, but looks to me like that's longer. Maybe if I went straight across, it would be shorter, or up. Where is it? That's what we're trying to find. So we are trying to minimize this distance. So let's just label the point where this line touches the parabola as the point xy. Then we're trying to find the distance from here to here. So this is what we're trying to minimize. D, which is equal to the square root of x minus 0 all squared plus y minus 3 all squared, looking at the distance between those 2 points. Of course, the y value has to be on the parabola, which means that another expression for the y is 6 minus x squared. So this becomes the square root of x minus 0 all squared plus y, 6 minus x squared minus 3 squared. Let's simplify that. So x minus 0 all squared is just x squared plus 6 minus x squared minus 3 gives me 3 minus x squared all squared. We'll FOIL this out And then last of all, collect like terms. So I've got x squared plus 3 minus x squared times 3 minus x squared is going to give me 9 minus 6x squared plus x to the fourth. And I've got two like terms here, and I'm going to write this in descending powers of x. I've got x to the fourth minus 5x squared plus 9. Okay, so I'm trying to minimize this function right here. So just have a look here. We can see that our minimum value has to be 3 or more. So I know this, that d is bigger than or equal to 3, which tells me that if I were just to maximize what's underneath the root, that I would get the biggest number possible when I took the root. So I'm just going to simplify my problem. To minimize a root, when you only need to minimize what's under the root as long as this number is bigger than 1, and we've already determined that it is. Okay, so we're going to just simplify this problem, and we're just going to minimize the part under the root. That is d, which is x to the fourth minus 5x squared plus 9. How do I minimize it? Well, take the derivative. And set it equal to 0. I'm going to take out the GCF, and that would give me 2x squared minus 5. So I'm going to have derivative equal to 0. Here's my critical numbers. X is either equal to 0 or plus or minus the square root of 5 over 2. Okay, so which one of those gives us a minimum? Well, to minimize, we plug this back into our distance formula and find out which one is smallest. So let's check x is equal to 0. If x is equal to 0, our distance is the square root of 0 to the fourth minus 5 times 0 squared plus 9. Our distance is 3. But hey, we already knew that, didn't we? Okay, let's check. X is equal to the square root of 5 over 2. Then my distance is equal to the square root of root 5 over 2 to the fourth, which is going to give me 25 over 4, minus 5 times root 5 over 2 squared, 5 times 5 over 2, plus 9. Let's give these all common denominators. I've got 25 over 4 minus 25 over 2, which would be 50 over 4, plus 36 over 4, which gives me 25 minus 50, negative 25 plus 36, square root of 11 over 4, or root 11 over 2. So trying to minimize the closest point, which point is bigger, root 11 over 2 or 3? This is the smaller one. Okay, so then what did the question ask? It didn't ask us what's the minimum distance. It asked us for the points that give us the minimum distance. So root 11 over 2 is the minimum distance. The points that minimize distance, and in fact there's two of them. One is when x is the positive square root of 5 over 2, and the other one when x is the negative square root of 5 over 2. And I think we can see that from the symmetry of this problem. If x is here and here, then we would have the same y value coming out. So let's figure out what it is. We got to go back there to find out what y is. What's y? Well, y is equal to 6 minus x squared. And if x is root 5 over 2, when I square it, I'm going to get 6 12 over 2 minus 5 over 2 gives me 7 over 2. So the points that minimize the distance are those 2 points. This is the minimum distance.